Hello, let's continue our Sudoku adventure with Pope Blonkus by Jean. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these black crop key dots in the grid. The way those work is they touch two digits, and those digits have to have a 1 to 2 ratio, meaning one is exactly double the other. So if this was a 2, this could be 1, because 2 is double 1, or it could be 4, because 4 is double 2. Those would be the options if this was a 2. All right. Not all the dots necessarily given, meaning if we had a 2, 4 here, there could have been a black dot. There isn't, and that's perfectly fine. All right, these purple lines are sequence lines. So along each sequence line is a sequence of digits in order with a constant difference, such as 1, 2, 3, 4, which would have a constant difference of 1, or 6, 4, 2, which has a constant difference of 2. So what you can't do is something like 2, 4, 2, because we have to keep going in this. You have to keep going up or keep going down. You can't switch direction. And the constant difference can be 0. So for example, 4, 4, 4 would be possible on a line where you're allowed to repeat on all three. I don't know that we have that in this puzzle though. All right, cool. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, so something I know about black dots. Let's see, but these don't see each other. So you can never put a 5 on a black dot. That's one thing, because 5 can't be doubled to 10. There's no 10, and it can't be halved to 2.5. So 5 just doesn't work. Now, normally I'd exclude 3, 6, but we can actually repeat the 6 or repeat the 3, and we can do 3, 6. So I'm not sure we can do anything with that yet. Right. This is a 4-length sequence line. So we could go a difference of 1, because we could do 1, 2, 3, 4, or 2, 3, 4, 5, or 3, 4, 5, 6. And can we have a difference of 2? So if we started with 1, with a difference of 2, we'd go 3, 5, 7. 7's too big. So then obviously starting with 2 would be worse. So this does have a difference of 1. And so the 1 and the 6 can only go on the extremes. These can't be 1 or 6. Because this could be 1, 2, sorry. This could be 1, 2, 3, 4, or it could be 2, 3, 4, 5, or it could be 3, 4, 5, 6. And we could go the other way. So we could have 1, 2, 3, 2, 3, 4. Oopsie. 2, 3, 4, or 3, 4, 5. So these can't be 1, 6, I guess is my point. A line like this, let's see. So we could have a difference of 1. We could have a difference of 2. We could go 1, 3, 5, or we could go 2, 4, 6. Can't have a difference of 3. So difference of 1 or 2. Same thing here. In here, and here. Ooh, what do we do with all that? So the middle cells can't ever be 1 or 6, just kind of by definition of them need to be a sequence. So these are all 2, 3, 4, 5. We know there's no 5 on here. So if this can't be a 5, I don't know how much that affects things, but whatever this is, okay, here's another little conclusion here, which is whatever this cell is, it is not on this line at all. Because if say this was a 1, we couldn't put a 1 in any of these cells. So this can only be a digit that isn't these 4. So if you remember, this is either 1, 2, 3, 4, 2, 3, 4, 5, or 3, 4, 5, 6. Let me write this out. 1, 2, 3, 4, 2, 3, 4, 5, or 3, 4, 5, 6. So if you think about it, we always have a 3 and a 4. There's no way to avoid that. So this cannot be 3 or 4. So this is from 1, 2, not 3, 4, not a 5 because of the black dot, or 6. So 1 would require these to be 2. 2 would require these to be 1 or 4, and 6 would require these to be 3. So they're from 1, 2, 3, 4. And, oh, whatever this digit is also isn't on this line at all because of the row in the box. So this can't be 3 or 4 either. So if it can't be a 3, this can't be a 6. That makes this a 1-2 pair. So we cannot put a 1 or a 2 on this line at all, making it a 3, 4, 5, 6 or a 3, 4, 5, 6. Very nice. Now that this is 1 or 2, we know we're increasing from there. So we could go 1, 2, 3. I don't see a reason that would be... Actually, no, we can't go 1, 2, 3 because this cell sees this 3, 6 pair here. One of these is 3, the other is 6. So this can't be 3 or 6. So we can't do 1, 2, 3. Can we do a 1, 3, 5? No, we can't. Because if this was 3, this would be 6, making this a 5. And that doesn't work with this 5. So this is never a 1. This is a 2, and that's a 1. And from the 2, we need to get a 1 or 4. So now that this is a 2, can we go 2, 3, 4? That seems reasonable. I don't see a reason that would be a problem. Or can we go 2, 4, 6? No, because this cell can't be 6. So we know that we're 2, 3, 4. That makes this 6, 5, 4, 3. That makes this a 1. This can't be 3 or 5. No, this can't be 3 or 4 now. Very nice. Okay, that was great. This is now a 5, 6 pair. So we're going to be decreasing down here by 1s or 2s. This can't be a 1 or a 2, though. This is 3, 4. So we're going to go down either 5, 4, 3 or 6, 5, 4. This here, we could go 3, 2, 1, or we could go 4, 5, 6. That's it. Because we can't go 3, 5. This is a 5, 6 pair. This is a 1, 2 pair. What else can I do here? What about these? How do these work? The 2 is just way too far away from the 5, 6. Remember, we have a difference of 1 or a 2. So this is a 4. So we could go 5, 4, 3. Or we could go 6, 4, 2. Okay. Yeah, I think we're good here. So this row we need 1, 2, 6. That's on a 1. What do I got here? 5, 6 pair. What else can I get? I need a 3 down here. He's up here somewhere. 1 in this box, one of these two. Okay, what am I missing? Clearly something. 6 in this box is one of these two. I mean, these are just 1, 2, 5, 6, I guess. So if this was 1, 2, 3, or it could be 6, 5, 4. There's a problem with either of those. Oh, we have a 5, 6 pair here, so this can't be 5. Okay, so that's 4. And that makes this 5, 4, 3. So that's 6, that's 2. We get the 1 and the 6, we get the 1 and the 2. We get our 4, which is going to go 4, 5, 6. We get our 1, 5, 6, 2. All right, up here we need a 3 and a 5. That's this order. This is a 3 and a 2. And then we just need the 1 through 6 in here. So the 1 goes here, the 2 goes there, the 3 goes there, the 4 goes there, the 5 and the 6. All right. Cool puzzle, Gene. That was really neat. I liked the logic of this sort of Pope hat here, for what it's worth. Because this cell, both of these cells on the black dot, seeing this entire sequence line, which had to have 3 and 4 on it. That was really neat. All right, cool. Well, let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.